Okay, here we are looking at rational inequalities, another version of non-linear inequalities. For the most part, these are just like the polynomial inequalities. First thing we want to do is get everything into factored form. Make sure, this is important, that we have some fraction greater than or less than or whatever than 0. This needs to be a 0. And we just factor everything because we need to know all of our factors. Okay, so my factors I'm dealing with here are x minus 8, x plus 3, and x plus 5. Anything that makes any of these 0 is a place, an x value, where this whole fraction could possibly change signs, where it could switch from negative to positive, or vice versa. So any number that makes either the top or bottom 0, any of the roots of my factors, goes on my sign chart. So let's do the smallest to largest, negative 5, negative 3, and 8. Don't worry about a scale. That's good enough. We list over here on the side all of our factors. Order doesn't really matter here. And we put in our dotted lines, make our grid, just like we did with polynomials. If you haven't watched the polynomial inequalities video yet, highly recommend you go watch that first. Okay, now we got to fill in all our pluses and minuses in each little box here. Remember, don't forget this section. We'll have 4 different sections where we're going to fill in pluses and minuses. Okay, each of these guys is going to switch from positive, negative, negative to positive only once. He's going to switch at 8 because that's what makes him 0. I mean, just think if you were to graph this, y equals x minus 8, that's a line that goes, ooh, it's negative before 8 and positive after 8. If you're not sure, plug in some x values. So in region 1 here, pick an x value. Anything less than 5, negative 5. Say negative 6. Negative 6 minus an 8 is a negative number. Pick an x value between negative 3 and negative 5 back here. Say negative 4 minus 8 is negative. Pick an x value between negative 3 and 8. Say 0. 0 minus 8 is negative. Pick an x value over here in region 4, something bigger than 8. Say 10, or 100, or 15,000.2, anything bigger than 8. 10 minus 8 is 2, positive. This guy switched right there. It's where it switched. This guy's going to switch right here. Negative 3 plus 3 would be 0. Anything smaller than negative 3? Negative 4 plus 3, for example, would be a negative. Anything bigger, say 5 plus 3 would be a positive. This guy's going to switch right here at negative 5. So right there, he's going to switch over. If I plug in any x value smaller than negative 5, I get a negative. Anything bigger, I get a positive. Okay, now we multiply down. 3 negative numbers multiplied together would be negative. 2 negatives is a positive. 1 negative is negative. 3 positives is a positive. Okay, so what did we want? Let's look back at our inequality here. I want positive. So the regions where I got positive, here and here. Those guys are good. Those guys are good. Now we got to be careful about our endpoints. This says greater than or equal to 0. So anything that makes the whole fraction equal to 0 is okay. But remember, you can never have 0 in the bottom. These guys here are automatically bad. I'm never going to have closed circles on negative 3 and 5 here because they're in the bottom. They don't make the whole fraction 0, they make the whole fraction undefined. What about 8? He's on top. Top is okay. I can have 0 on top. If I plug in x equals 8, I would get 0 over stuff, just positive. So 8 is good. Top is good, bottoms are bad. That's all you got to remember. The top is closed circle, bottom's open circle, if you have this equal to. Okay, so let's write this as an interval from here to here. Guess we'll write it over here. Is -5 to -3, parentheses on both. The 8 we said was good because he was on top, so 8 to infinity. So there's our solution. Those are the list of all the possible x values I could plug in to this side so that the whole fraction would be greater than or equal to 0. Okay, another one. Okay, this guy's already factored. I don't have to do much work here. I draw a number line. On the number line, I list anything that makes any of my factors equal to 0. So I have 3 factors. I'll have 3 numbers on my number line. I've got a -6 right here, a -4, and a 1. Draw on my dotted lines. You see I'm going to have 1, 2, 3, 4 different regions. I kind of lost my 1 there with my dotted line. Okay, list my factors. Okay, I like to also put in these dotted lines, dashed lines if you like, so they can clearly see where all my boxes are. That's where these go wrong, is people lose boxes. Okay, this guy's going to switch at 1. He's negative below 1, positive above. This one is going to switch at 4, at -4. Right here, he's negative below, positive above. Where's this guy going to switch? At -6. He's negative below, positive above. Should kind of see a pattern happening here. 3 negatives multiplied together is, I almost wrote positive, is a negative. 2 negatives is a positive. 1 negative is a negative. 3 positives is a positive. What did I want? I want less than 0, right there. That's negative. I want, let's use a different color here, all those negatives, all those negatives. I don't have an equal to here. This is strictly less than 0, so automatically I don't have to worry top or bottom. Everybody's open circles. If you have the greater than or equal to 0, the less than or equal. If you have the equal, you might have some solid dots, but if there's no equal to, they're automatically open circles. So this region here is -infinity to -6, and this region is -4 to 1. Okay, now it's going to get a little more complicated. Okay, let's say we wanted to solve this. I know what your first thought is. Your first thought is, let's cross multiply. You can't do that. You cannot cross multiply. I promise you, you are going to get the wrong answer if you cross multiply. Guaranteed. Because remember, whenever you multiply an inequality by a negative, you're supposed to switch the signs. So you would have to do this whole really long, complicated mess and say, well, if x is less than 6, then this flips over. And if x is greater than -6, it does. You don't want to do that. Trust me. You need this to be a 0. So I need to get everything on one side. That's your first step. Get everything on one side. Okay, now we're going to do a bunch of complicated math, because I need this side now to be in factored form, which means I'm going to have to combine these fractions together. Remember, this is really 3 over 1. So I'm going to have to find a common denominator here. So I've got an x plus 6 and a 1, my common denominator is x plus 6. So I have to multiply top and bottom of this fraction by x plus 6. Okay, so that will give me x plus 36 over x plus 6 minus, distributing that minus, let's write this all as one fraction, minus 3x minus 18 all over x plus 6, and that is supposed to be less than or equal to 0. Okay, so we end up with negative 2x plus 18 over x plus 6 less than or equal to 0. X minus 3x is negative 2x. 36 minus 18 is positive 18. Okay, now I factor. The only thing I can do here is factor that negative 2 out of the top. Yeah, let's just factor a 2 out. So things are going to get a little weird here. I could have factored the negative 2 out, but that would end up changing all my signs. So I'm not going to do that. There are other ways we could take care of that negative. We can move everything to the other side and make sure that's positive. There are other things we could do, but here's one way that will work perfectly fine. I just factored the 2 out of the top. Okay, so now what are my factors? My factors are negative x plus 9, x plus 6, and 2. Does 2 ever equal 0? No. That 2's not doing anything. In fact, I could if I wanted to just divide the 2 out. That 2 is not changing anybody's sign. 2 is always positive. It doesn't belong in my sign chart. It's not going to belong in my list of factors. It's not going to go anywhere. So I don't worry about the 2. What number makes this factor 0? What number would I have to plug in for x to make this whole thing 0? That's positive 9. If x equals 9, I would have negative 9 plus 9, I would have 0. What about the bottom? That would be negative 6. Okay, I list my factors over on the side, negative x plus 9 and x plus 6. I have my 3 regions here. Okay, now we fill out our sign chart. Now we got to be careful because we got this negative in front of this x. Everything is going to be backwards. All the games we keep playing, negative on the left, positive on the right, that's not going to work anymore because I've got a negative in front of the x. Like, let's pick some actual x values and you'll see. Like over here, let's say x equals 10. Negative 10 plus 9 would be negative 1. What about between negative 6 and 9? Pick an x value. Say, I don't know, 2. Anything between negative 6 and 9 would work. Negative 2 plus 9 would be positive 7. That's a positive. And what if we pick something back here? Negative 8. A negative 8 plugged in here would be negative 8, positive 8, plus 9 would be 17. It's a positive. Okay, so this guy still switched at 9. Kind of lost my 9 a little bit there. He switched at 9, but he's backwards. He's positive and then switches to negative. This guy's normal. He's just x plus 6. He's going to be negative below, positive above. Again, we can plug in our x values and check. Negative 8 plus 6 is a negative number. 2 plus 6 is positive. 10 plus 6 is positive. Okay, we multiply down. Positive times a negative is a negative. 2 positives is positive. 1 negative is negative. Now I have to go, where can I go? Here I didn't even have a 0. It's here. This is where I have to go. I have to wait until I got that 0 involved in the problem. I wanted negative. So negative is these two regions. Try to color code this. Over here and over here. I got to be really careful with my endpoints now, though. Anybody that makes the bottom 0 is automatically excluded. Who makes the bottom 0? -6. He has to be an open circle. Has to be. Okay, what about the 9? 9 made the top 0. That's okay. I'm allowed to have 0 on top. In fact, I want 0 on top. So that's a closed circle. Tops are okay, bottoms are not. Okay, now we write down the answer. This is -8, negative infinity to -8. Open circle, so parenthesis. Union, 9, bracket, because of the closed circle, to infinity. Remember, infinity always gets a parenthesis. Okay, one more example that's honestly a little worse than that one. Okay, say we want to solve this guy. Again, you might think, hey, I'm going to cross multiply. Promise you, you're going to get it wrong if you do. It's not going to do you any good. Do not cross multiply. Do not cross multiply. You have to subtract. Move everything, or in this case, because it's negative, add. Move everything to one side. So this would become -3 over x plus 7 plus 4 over x plus 8 is now less than or equal to 0. And just move this term to the other side. Okay, now I have to get a common denominator. My LCD here is just going to be these two multiplied together. X plus 7 times x plus 8. So this first fraction is missing an x plus 8, top and bottom, plus the second fraction has the x plus 8, he's missing the x plus 7, top and bottom. Don't forget about this. Okay, now I've got a common denominator. I'll be able to add the numerators, so let's distribute. I'll get -3x plus 24 plus 4x plus 28 all over this stuff here. And that's supposed to be negative, less than or equal to 0. And this, when we distributed, -3 times 8 should be -24. Okay, so let's simplify here. 4x minus 3x is just x. 28 minus 24 would be plus 4 over x plus 8, x plus 7, less than or equal to 0. That's a 0. Okay, now we're ready. We have to get it in this factored form first before we start doing sign charts and factors and whatnot. We have 3 factors, x plus 4, x plus 7, x plus 8. I think we can squeeze them in here. So we'll have -8, -7, -4 as my roots of all the 3 factors. List out my factors on the side. Order doesn't really matter here. Okay, drawing all our little dotted lines. I know I don't get these right if I don't draw in all the dotted lines. I'm guessing you probably won't either. Make this grid. Okay, fill in all of our pluses and minuses. I'm telling you, the easy way is figure out where they switch. X plus 4 is going to switch at -4. Just to make sure it's clear, these are all negatives. He's going to switch at -4. He's negative below that, and he's positive above. X plus 8 switches at -8. He's negative below, positive above. This guy, x plus 7, switches right here at -7, negative below, positive above. Multiply down, 3 negatives is negative, 2 negatives, positive. 1 is negative, none is positive. Okay, now I have to go back, and up here is not going to do me any good. I got to figure out where 0 came in. Right there. There's the first instance of 0. I want less than 0, negative. That was these two regions here, the two negative regions. All good? All good. Anybody that makes the bottom 0 is automatically excluded. I don't care if I got the less than or equal to or not. Whether or not I have the equal to, guys on the bottom are excluded. So that would be the -7 and the -8 are both excluded. Because I am allowing for equal to 0, the guy on top, the -4, is okay. He's a solid. Okay, so my answer is going to be all this stuff below -8, negative infinity to -8. He's a parenthesis because of the open circle. And then -7 to -4. He's open circle because he was in the bottom. The -4 is a bracket because he was on top. Okay, that is rational inequalities. Popping up here should be the video for polynomial inequalities. If you didn't watch that one first, you should really go back and watch that one, then come back and watch this one again.